several pieces involved in the network policy deployment. As you may have read, policies themselves are already supported by the Kubernetes, but they have a hard prerequisite on containing network provider with the support for network policies. And we selected Cilium as such provider for this MVC. So the first step deploying network policies will be to set up a cluster with Cilium. We do that through the new thing called cluster management application. And the way it works is you'll create a cluster. For example, in my demo project, if I will go under the Kubernetes settings, I already have a network policy cluster created for the GitLab. And one important thing to do is you have to assign a cluster management project to this cluster. You do this by selecting another GitLab project in this dropdown, pressing save. In this particular instance, I have already assigned a network policy cluster management repository to be a management project for this cluster. So if I will switch to the management repository, this one, the structure is pretty simple. It relies on CI runner to deploy management applications to the cluster. You don't have to create a cluster in this repository. Cluster automatically will be derived from the settings we just assigned. Setup process is quite simple. GitLab ships a template that you can use in your CI configuration. So it's essentially 2 lines that you have to assign in your CI config. And by doing that, you will be able to enable certain applications in your cluster. For this particular repository, we have enabled an Nginx ingress to be deployed to this cluster and Cilium to be deployed to this cluster. So I have already run the pipeline for that. So if you will go into the log, for example, one of the older ones, you will notice that there are a lot of lines that will involve Helm. It's essentially will show you which Kubernetes resources will be deployed by the Helm, and you can see everything in the output in all the details that you need, and you can control the deployment process for the CI pipelines. So if we will go back into the actual demo project, this is the second part of our work that we did. So essentially, this is a simple Golang application that Damir did. It has a simple web interface, and it also has a support for one post request that essentially a ping response, like a ping pong application. We are deploying this application through the AutoDevOps pipelines. We are using the same AutoDevOps as normally. We just removed unnecessary stages like assessed and dest, because it's a really simple application and did not want to lose any time on that. The actual network deployment application is enabled by defining your network policy inside the .gitlab folder in AutoDeploy values file. So you can see if I go this file, there is a network policy defined for this particular application. First of all, you have to obviously enable network policy. By default, network policies are disabled. And then you have to provide the specification. Specification is optional. This actually is the default policies that defined by us. It doesn't have to be in here. Right? I will change it later on. Just enabling here is enough. So what this policy does, it only affects ingress. It also will affect all pods within this particular application namespace, and it will allow traffic from all applications within this namespace, but it will also allow all ingress traffic from the namespace is managed by GitLab. In this particular application, this namespace is namespace where we installed Nginx and Grass. So yeah, this one was already deployed. So the Zamir did that. This simple UI allows you to ping another application deployed to this cluster, and it will work based on the namespace and the service that is deployed to the cluster. Obviously, by itself, it doesn't do much. So what we did, we actually set up a second application from the branch of this repository. It has slightly different policy. As you might notice, it also adds an additional block, and this block essentially whitelist and Grass traffic from the apps that I just showed you. It does it by selecting that namespace using two labels, and you can see the app name is GitLab.org defend NetworkPolicy demo. It's a name that is generated automatically by CI runner for this application, and we only target production environment. So we are flexible to choose different labels. There are several combinations that you can use, but for our use cases, most interesting one. So again, I will go and try to find, yeah, I think it's this one. Yeah, it's a different app. And they look exactly the same. So yeah, what we can do is we can point this app to try to access this app, and this one should not succeed. But if we will go in opposite direction, it should succeed that based on the policies that we deployed. So we're pointing, I'm pretty sure, to this, and the service name is that, and this one is will be this, and I think this. So this one should success. Yeah, you can see I can ping that from master branch to the whitelisted branch, but if I will go in opposite direction, it will not succeed. It will be failing.
So what I am seeing is that there are two different applications that have been deployed to a Kubernetes pod, each of which has their own network policies that have been applied. One that has been completely locked down, it can only talk within its own application. One that has been opened up so it can speak to other applications within the pod itself. And what this UI is showing is that the network policies are doing their jobs, where one is allowed to connect out to other applications and the other one cannot. It has been completely isolated.